Have you ever just stared at a math problem on a big exam and felt your brain totally freeze up? Well, today we're going to take one of those questions and turn it into a super easy win. We're going to break down some seriously clever shortcuts that, honestly, the people who write these exams hope you don't know. So here it is. This is a real question from a competitive railway recruitment exam. You've got four pretty intimidating numbers. The challenge, you got to find the one that's divisible by both 9 and 11. Now, it looks like a total nightmare of long division, right? But it's actually a fun little puzzle just waiting for us to solve it. And here's the real kicker. In that exam hall, the clock is just ticking away. You don't have a calculator, and you've got maybe a minute, tops, to figure this out. It feels impossible, but that's exactly what we're here for. We're going to beat that clock. Okay, so here's our game plan. We're going to tackle this problem by learning two really powerful shortcuts, the rules of 9 and 11. Then we'll use them to solve the question, peek behind the curtain at the cool math that makes them work, and then we'll finish up with a pro-level trick that ties it all together. Let's get started. First up is our initial weapon, the rule of 9. Now, I want you to think of this as a quick filter. Its whole job is to help us get rid of the obvious wrong answers right away, which is going to save us some precious time and brain power. The rule itself is it's beautifully simple. You don't need to divide that big, scary number. All you do is add up its individual digits. If that sum is a multiple of 9, like 9, 18, 27, then the original number is divisible by 9. It's an elegant and incredibly fast shortcut.
All right, let's put it to the test. Option A, the digits add up to 27. That works. Option B sums to 18. That works too. Option D adds up to 36. Another pass. But look at option C. The digits sum to 15. And since 15 is not divisible by 9, we can immediately cross 1, 2, 3, 4, 5 off our list. Just like that, we're already down to 3 choices.
You know, exams are often designed this way completely on purpose. They give you options that pass that first, easier test. These are what we call strong distractors. To find that one single correct answer, we're going to need a more powerful tool. And now for our second shortcut, the rule of 11. This is the deciding factor. It's a little more involved than the rule of 9, for sure, but this is the tool that's going to separate the correct answer from those really tricky distractors. Okay, I know this one sounds a bit weird at first. So you take the digits, but you separate them into 2 teams, the ones in the odd positions, so the first digit, the third, the fifth, and so on, and the ones in the even positions. You sum up each team, find the difference between them, and if that result is 0 or something divisible by 11, you've got a match. Let's just walk through it with one of our remaining candidates, 1098. The odd position digits, that's the first, third, and fifth, are 1, 0, and 8. Add those up and you get 9. The even position digits are 0 and 9, which also sum to 9. So we take the sum of the odds, which is 9, and we subtract the sum of the evens, which is also 9. The result is 0. Now, according to our rule, if the difference is 0 or a multiple of 11, the number is divisible by 11. And bingo, looks like we have our winner. All right, we're heading into the final showdown. We've seen that 1098 passes both of our tests. But hey, a good test taker always double checks. So let's quickly apply the rule of 11 to our other 2 candidates just to be absolutely sure. Okay, checking our other options. For number A, the difference is -7. Nope, not divisible by 11. For D, the difference is -14. Again, not a match. This confirms it. Only 10,098 satisfies both conditions. It passed the rule of 9, and it passed the rule of 11. That is our answer. But what about those other options? This is where we get a really cool insight into how exams are actually made. Take a look at number A, 277218. You see that repeating 2772 pattern? That's there to trick your brain, to make you see a symmetry that isn't really there mathematically. These distractors are designed to make you second-guess yourself if you don't apply the rules perfectly. So we know how these rules work, but for those of you who are curious, let's take a quick peek at why they work. I promise these aren't just magic tricks. They're based on the fundamental structure of our good old base 10 number system. The rule of 9 works simply because any power of 10, like 10 or 100 or 1,000, is always just one more than a multiple of 9. So when you break a number down, what you're really left with is the sum of its digits. The rule of 11 is kind of similar, but it alternates. 10 is 1 less than 11. but 100 is 1 more than a multiple of 11. This whole +1 -1 pattern is exactly why we do that alternating sum thing.
All right, you've mastered the basics. You can solve the problem. Now it's time for the grand finale. This is the ultimate pro-level trick that combines both of our rules into one super fast check. This is for when you want to solve this kind of problem in, like, under 10 seconds.
So here's the logic. Since 9 and 11 don't share any common factors other than 1, they're called coprime. What that means for us is that any number divisible by both of them must also be divisible by their product, 9 times 11, which is 99. So the question isn't just asking about 9 and 11, it's secretly asking which one of these numbers is divisible by 99.
And there's a really beautiful shortcut for checking divisibility by 99. You take the number, in our case 10,098, and you split it into blocks of 2 digits starting from the right. So we get 98, then 00, and then the one that's left over. Now you just add those blocks together. 98 plus 0 plus 1 equals 99.
And there you have it. Since the sum of those blocks is 99, which is obviously divisible by 99, the original number is also divisible by 99. This gives us a much faster, more elegant path to the same answer, confirming our result with a completely different method.
So we've taken a pretty tricky exam question and completely dismantled it with a few powerful rules. It just goes to show you that underneath the surface of problems that look really complex, there are often these elegant, simple patterns just waiting. Which kind of leaves us with a final thought. What other hidden numerical shortcuts are out there, just waiting for us to discover them?